Hello guys, we're back. In my project I found out that a lot of people don't know that because I just took things from space and air and so on. So I wanted us to look at some functionalities that really help us in this electronic work, like the function of the multimeter. The function of the multimeter, it's a multimeter is a device which is used in measuring current, voltage, resistance, continuity, and other forms of technical work. Now we're going to look at the two main categories of things here. We're going to look at first the structure, and then we're going to look at measurement. Under measurement, we're going to have four basic factors, which include measurement of voltage, measurement of current, measurement of resistance, and measurement of continuity. Now, before we go ahead, we want to look at the structure first. Look, the multimeter was made, there have been multimeters in different categories and different advanced technologies. There are multimeters with 4 ports, but the one I have here definitely is 3 port. As you can see, the multimeter I have here is has 3 ports. It has the port for DC measurement on fused. It has the port for where we have measurement of voltage, same resistance and current, and it has a fuse port, which is the common port. And these ports are used for, let me say, plugging in these cables for whatever you're testing, right? The box here is a sound indicator, but this one currently doesn't function because this is a very low level multimeter. Usually if you want to buy a multimeter, don't buy this one now, but we are going to use it in our test because it's going to do us some basic tests. What about those who can't afford? So now we're going to start with first measurement of voltage. Let's see if we're measuring the voltage of a resistor like this. What do we need? Now we want to measure the current, the voltage. What is voltage? In a very simplified term, we say voltage is like current pressure. The pressure current applies on a device or battery or power source. The force applies a pressure. That pressure is what we call voltage in electronic devices. And what this multimeter simply measures is it simply measures the pressure in terms of current. It simply measures the pressure in terms of current, which is known to us as voltage. Next, we're going to look at current, which is the volume. Current is simply the volume. When you talk about volume, what do you mean? The amount of electricity, that this current, that the object has. The volume, it's what we refer to as current. So if we are measuring the current using our multimeter, then we're simply measuring the volume of electricity. And if we're measuring the voltage, then we're simply measuring the pressure of electricity. Good. Just like Nikola Tesla. Now, next we're going to look at resistance. Resistance is like an opposition. It's like an opposition to flow of current. It's like an opposition to flow current. Imagine a pipe of a water pipe. Imagine water flows through this point and you block it. It's not really blocking it. Resistance is like narrowing down the link, narrowing down the pathway. It's like passing the water from a large part to a lower part, like this. If we have now a big pipe like this, now resistance kinds of is the opposition to the flow of current. It's like a barrier, not really stopping the flow of current, but it opposes, it provides some kind of like the like a rejection. It doesn't want any movement of current. It doesn't want that increase in volume or something, that pressure. It doesn't read that. And from these three factors, we have been able to demonstrate a lot of things about current and electricity. Now, enough talking. No, let's go to, we've forgotten. Let's talk about continuity. What is continuity? Imagine you have uh, let's say a screwdriver, or what about a chainsaw, and you want to know if it is detached. Well, continuity helps us a lot because we want to see how continuity is like trying to know if there's a break. Does the current we apply on this metal bar flow from here to here? Is the bar broken? So continuity is like to know if it is continuous or if there's no breakage or leakage or something. Most times continuity helps us in knowing a lot of circuit problems. Imagine a capacitor is bad and you want to know if it's working. You could just simply use the multimeter to test for continuity. Okay, resistance too, it's a very good way of knowing about continuity, but most multimeters these days have a sounder and they tell you a lot about continuity. Now, let's leave all this bullshit. Wait, let me tell you about bullshit. Now, let's leave all this crap and go to the work at hand. Good. So here's our multimeter, and if you can see, it has like 5 or 6 sections, maybe. It has the DC voltage section, it has the AC section, AC voltage. Oh, rest forgot. There's a difference between AC voltage and DC voltage. Now, it has DC amps, that's current measurement. That's it has resistance section. You see it's green. It has one fuse. The word, I don't even know what that means. Okay, now it has 3 ports, as we earlier said. The middle port is for the red cable, which you plug in for all measurements of voltage, current, and milliamperes or something. And this is the fused one. It has a fuse, so it can take up to a maximum of let me say 700 volt amperes, or maximum of 200 milliamps, maximum 200 milliamperes maximum. And so if you're measuring devices which are above 200 milliamps, you are advised to use the unfused port, but that is very damaging as it can destroy a lot of equipment or yourself. The black cable goes to the common port, which is for measuring, for rotation current and so on. It is the fused port anyway. So we plug it in. Now let's start our first one, which is voltage. As we said, pressure. We want to measure the pressure of equipment or battery. So first we need a battery. So where do you think we can get a battery? We need a battery. Okay, I don't know. I have so many batteries. Good. Now, if we need a battery, we'll need to know how we can measure the voltage of any battery of any sort. So we have a 1.5 volt battery. This is normally the battery used in your equipment, remotes or something. So we're going to test its voltage. We're going to test its voltage to see how that works. You're going to read the voltage on the multimeter. So you see it's approximately, should be 1 point something, it should be quite low right now. Should be quite low. You see 1 point, oh, that's a lot. So it's showing you approximately 1 point something volts. And if you see your multimeter giving you readings where you're not actually connected to anything, you know that it's it's just a magnetic field you can take from the air. So even you see this is not very much connected to anything, but it's giving reading. So just know they are just magnetic fields that are it's picking up from surrounding or something. So let's go back to our measurement of voltage. As you can see, measurement of voltage. Let's be frank, you know where we put the, as you can see from off, we turn it down to the lowest part of DC voltage measurement because the battery has DC voltage. So you want to measure DC voltage. So you take it, it has a reading of 1200 volts. So I think this is a 1.5 battery. So the range of the voltage should be around 20. 20, it's very much so, but we can take it to be millivolts, but I'll prefer we take it 20, so it gives us approximately 1.5. What do we want to see? So we're going to take the two arms now, and we're going to do the measurements. We're going to do the measurements. See, it's quite low. It's quite low. It changes. See, it's a negative. Oh, did you see that? There's a negative sign which appeared. Oh, we got a negative sign. Shows that the battery is wrong. The terminals are not connected, or the current is flowing in a negative direction, or the voltage. So to get that, we just simply exchange the wires and put the positive where the positive belongs and the negative where it belongs. So that way we'll be able to like see what we have to see. So you see it's quite low. It has like 42 volts, 0.42, 0.45. So it's quite low. So normally it shows you the reading, actual reading. Showed the battery is quite low. So this battery is almost dead. In a few moments it'll be like gone. So now we're going to do other high voltage measurements, like for example we're going to measure our AC voltage for our distributor. Normally in Cameroon we take up to 240 volts AC supply. So but this is going to be different, other than you can see the distributor is well connected. So we're going to change the measurement technique. Now we're going to go to AC voltage measurement, which is here. If you can see, this is AC voltage, so we're going to turn it. Since we take up to 240, we'll put it at a high voltage measurement, which is 750 AC volt supply, and we will do the measurements as follows. Oh, no, so if you see it's changing. Wow, even now suffer from low voltage. You see it's 164 volts, 164 volts, 156. So it's approximately 150, 164, 66. So it's even low. It's not even. Oh. So that's the voltage of our AC supply, which is very low compared to our normal or rated home rating voltage, which is 240 volts. Now we're going to do other measurements of DC volt measurements. DC. We're going to plug a 5 volt charger on current and try to see if it produces the current we are talking about. Let's take a tour, and if you see, this is a 5 volt charger. If you take note, 0.15 amperes, good enough. Okay, that's it. Output is 5 volts, as you can see on the level right here, 5 volts. So we're going to kind of do a little test to see if it has the voltage reading on its, to know if the chargers or the supply is working perfectly, what it should be. So I took the liberty of uh peeling it off. As you can see, it's peeled off. So we're just simply going to take the terminals of our multimeter and try to test if the voltage reading is approximately 5 volts or more. Okay, that's kind of resistance. Oh, dudes, don't forget, it's DC voltage. Ah, see, 5.36. Nice and good enough. Nice and good enough. Nice and good enough. So 5.4, that is the voltage of the charger, and shows very much good. So that's how much pressure electricity is putting on that wire or the electrical system of this. So now we're going to do the measurement of resistance. The measurement of resistance. Now, it is very advisable that when measuring resistance of a wire or an equipment or device or whatever you're measuring the resistance and continuity of the device, it is very advisable not to connect the device to uh, an electrical source or energize the device or give it some kind of power or something. If you want to test the electrical resistance of a device like this, which is in a rust cable, you should be able to turn off every connection that is attached to it. Let's now go to resistance and go to the board where we actually get to use resistance. So we're going to take the dial pad where you have the dot. If you see the dot, yeah, we're going to turn it down to resistance where we have ohms symbol, and if you see, that is it. That is it. Now we're going to measure the resistance of a battery first. Let's see if a battery has a resistance. So we're going to test the resistance of a battery. Oh, it does. Did you see that? Very high resistance for a little battery like that. See, it comes off and goes off. Seems like the continuity is not really good. This can't even pick up anything. Rust is destroying it. Well, that's a bad one for continuity and resistance. So next we want to look for a good device which will really give us a continuity or resistance. Oh, what about the resistance of the multimeter itself? Yes, if you see this, you see that there's a resistance of 0. Of 0, yeah, of 3 ohms. It's a resistance of 3 ohms. That's not point, that's 003. There's a resistance of 3 ohms. Remember, we're at 2000. If you go to 200 or go to 20 kilo, if you go to 200, we see that that is 30.322429 resistance, which is quite very much for a small device. Okay, so that's the resistance of the entire device, but you know that's wrong, right? Why? Because it's connected to an electrical, to a battery source, which is not really correct. Let's check the resistance of this metal device. Oh yeah, so if we try the metal device, we see that it's about 27 to 25 ohms of resistance we're dealing with here, which is good. So this resistance really helps us in knowing continuity too, because if there is you know the resistance rating of a metal and that you just bought, and if you test and the resistance is not what it should be, that means the device is not functioning properly. So resistance is very necessary in many cases. And last test, we're going to do continuity. Like we said, this our multimeter is not very advanced enough for continuity, but continuity can also be known with resistance, and that's what we intend showing you. An object, let's say we want to know the resistance of or something like a wire that is connected to 2 points. To know if it's connected, then they should have a resistance when we touch two ends that are attached together. So now we're going to see, for example, let's take this. See, this is the device. If it should have a resistance, then it should have continuity. Let's try. Everything is to try. Waiting, trying to find a device where we expecting resistance that is a really high resistance. So that shows you continuity too, because if there's a resistance in here, that means the object is connected. The object is very much connected. As you see, the resistance is about 53 to something ohms, and 56.99. That means there's continuity. That means this part is connected to this part. This part is connected to this part. So what if there was no connection between this part and this? Then we wouldn't be able to get some kind of resistance. You see, there's continuity. This is a junction and this is a junction. Now let's take this and this and see. There is continuity and there is resistance. So resistance also helps us in that continuity test. In our next video, we should be looking at function and parts of some basic motherboard equipment like resistors, transistors, diodes, amplifiers, and transformers. And we're going to see how we can ordinarily use a transformer. For example, this is a transformer. So we're going to see all those in our next video tutorial. Thank you for watching. I hope you subscribe or bring more views.